Hi guys, so today we are reviewing 3D through 3E. So let's get started. So first of all, number one, you're not expected to do anything. It's just a reminder that you should know all of these terms. You should know their definitions, their properties, and what they look like on a picture. So I suggest doing flashcards. On one side you have the word, on the other side you have a picture of it, its definition, and any of its properties. So the first question where you actually have to do something is number 2. So here it says to find the sum of the measures of the interior angles of the polygon. And so that is with this formula. It's n minus 2 times 180. N represents the number of sides. Let's get started. Okay, so first here, this is a pentagon. That means that n equals 5. So then all we have to do, plug it in. Okay, so 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180 is 540 degrees. So a pentagon totals to be 540 degrees. Okay. Next one here is a heptagon. Heptagon has 7 sides. So 7 minus 2 times 180. 7 minus 2 is 5. 5 times 180 is 900 degrees. Okay. Next here is dodecagon. That is for a 12-sided polygon. So n equals 12. Okay. So 12 minus 2 times 180. 12 minus 2 is 10. 10 times 180 is 1,800. Last one here is a 17gon. That would mean that it has 17 sides. So 17 minus 2 times 180. 17 minus 2 is 15. 15 times 180 is 2,700. Okay. The next two problems here, we're going to use the exact same formula, but this time we're actually going to find what the angle is, not what the sum is, but what each angle is. Okay. So here, I have a pentagon, right? 1, 2, 3, 4, 5. If I didn't solve it earlier, right, I would have to solve for it. So just to get in the practice, we're going to solve for it. Okay. So here it's a pentagon because it has 5 sides. So as a result, 5 minus 2 times 180, that gives me 3 times 180, which is 540 degrees. So what that means is all of these angles added up together should total to be 540. Okay. So from this picture, here I see that angle A has 2 arcs and it's labeled with X, and so is this angle here, which means this is X number of degrees as well. Okay. Then this one's 108. These have the right angle symbol, which means that each of these are 90 degrees. Okay. So they should all total up to equal 540. So what that means is 108 plus X plus 90 plus 90 should equal 540. Right? X plus X is 2X. 108 plus 90 plus 90 is 288. Then all I have to do is subtract 288 on both sides. And I get 2x equals 252. And then since this is 2 times x, get rid of it by dividing by 2. X equals 126. Okay, here I have the next one. This is a quadrilateral because it has 1, 2, 3, 4 sides. So n equals 4. Which means that for a quadrilateral, 4 minus 2 is 2. 2 times 180 is 360. A quadrilateral totals up to be 360 degrees, which means that the 85 plus the x plus 37 plus the 69 plus 6x plus 22 totals to be 360. Okay. So combining like terms, x plus 6x is 7x. 85 plus 37 plus 69 plus the 22 gives me 213. And again, it all totals to be 360 degrees because it's a quadrilateral, four-sided shape. Okay. Then I solve, subtract 213 on both sides. This gives me 7x equals 147. Divide by 7 on both sides since this is 7 times x, and I get x equals 21. The next two problems are exterior angles. While these are inside of my polygon, these ones are outside. They are exterior angles. Okay, and so the formula for this is that sum of exterior angles is always going to total to be 360 degrees. It doesn't matter if it's a quadrilateral or a heptagon here, it should always total to be 360. Okay? So that makes it nice and easy. So that means x plus 78 plus 80 plus 90 totals to be 360. 78 plus 80 plus 90 is 248. Then subtract 248 on both sides, and I get x equals 112. Okay. Here's the next one. Okay. So again, exterior angles always total to be 360. It doesn't matter that this has 7 sides. Okay. So that means x plus 58 plus 39 plus 50 plus 48 plus 59 totals to be 360. X plus x is 2x. 58 plus 59 plus blah 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 totals to be 254. Okay. Get rid of the plus 254 by subtracting 254. Okay. And so 2x equals 106. 2x is 2 times x. Get rid of it by dividing by 2, so x equals 53. Okay. There you go. Okay, the next section here is to find the value of each variable on the parallelogram. Okay. So some characteristics of a parallelogram. Okay. So first of all, definition of parallelogram, opposite sides are parallel. What we also know is opposite sides are congruent. Okay. Opposite angles are congruent. Okay. And we also know that the diagonals bisect each other. And that angles on the same side, because they will end up being same side interior angles formed by parallel lines, angles on the same side are supplementary. Okay, so let's get started. Okay, so here are my different parallelograms. So first of all, here we have side lengths, and we know that opposite sides are congruent. What that means then is that m plus 1 equals 6, and that n equals 12. That's what I'm going to write. So m plus 1 equals 6 here. See that? Then all I have to do is subtract 1 here. M equals 5. Okay. Then here, from what we see with the orange, n equals 12. Next one here, again, opposite sides are congruent, so that means the 20 and the z minus 8 are equal to each other. So z minus 8 equals 20. Add 8 on both sides. Z equals 28. We also know that opposite angles are congruent too, so that means the 105 degrees equals the d minus 21. And so when I add 21 to both sides, d equals 126. Okay. The next thing we know is that the diagonals bisect each other. And so what that means is that the b minus 1 equals the 9 here, and the 15 equals the 5a. Okay. So b minus 1 equals 9, because the diagonals bisect each other. Add 1 to both sides, b equals 10. Same thing here then. Diagonals bisect each other, so 5a equals 15. Since this is 5 times a, get rid of it by dividing by 5, so a equals 3. Okay. Then here, it asks us to find angle B, angle C, and angle D. So again, for a parallelogram, opposite angles are congruent, so A and C would be congruent. So since angle A is 51, angle C is 51. Okay. Then we also know, again, opposite angles are congruent. So angle B and angle D here. Okay. And we know that angles on the same side are supplementary. And so what that means is here that angle A plus angle B, angle B, they are same side interior angles, okay, so they should total to be 180. Angle A we know is 51. And when I subtract that 51, angle B is 129 degrees. So it's 129. And since this is 129, the opposite angle for it, for a parallelogram, is also going to be the same. So that's also 129. Okay. Now let's flip. So the next portion is a rhombus. So let's define our rhombus. So rhombus is a parallelogram with 4 congruent sides. Then the other thing we know about rhombuses is that the diagonals bisect the angles. They cut it into 2 equal halves. Okay. And we know that the diagonals are perpendicular to each other. So what that means then, my parallelogram with 4 congruent sides, since this is a rhombus, that means this side is equal to this side is equal to this side is equal to this side. Okay. Then, since the diagonals bisect the angles, since this is 55 degrees, this would be 55 as well. And because it also applies to parallelograms, right, because a rhombus is a type of parallelogram, it's congruent. So opposite angles are congruent for a parallelogram. This would be 55 and this would be 55 as well. Okay. And then the other thing is that we know that the diagonals are perpendicular. Okay. Which means then, this is perpendicular, because these are my 2 diagonals. Okay. So let's start with angle DAC. So angle DAC is actually here. Okay. And like we said, because the diagonals bisect this angle, it cuts into 2 equal halves. Since this is 55, this one is 55 as well. Okay. Next one here is angle ADC. So ADC, so angle ADC is this whole thing here. Okay. Because a rhombus is a type of parallelogram, the parallelogram rules tells us that same side here, this here, they share this side. They are same side interior angles. They are parallel lines here. They will be supplementary. So what it tells me is that all of angle A and all of angle D, they should total to be 180. So since this is 55 and 55, that means it's a total of 110. So this here, all of angle A, which is 110, plus all of angle D, which is angle ADC, should total to be 180. So when I subtract the 110, that means angle ADC is 70 degrees. Right? Then the next one here is asking for angle BDC. Right? BDC, so angle BDC is right here. And again, because the diagonals bisect the angle, this total is 70 degrees. Right? When it is bisected, it is cut into 2 equal halves. So that means angle BDC is half of 70, which is 35. Okay. Then last one here, angle DEC. DEC, that's here. Okay. We know that the diagonals are perpendicular. They are perpendicular to each other. So angle DEC is 90 degrees. Okay, next one here is a rectangle. Okay, so definition of a rectangle, it is a parallelogram with 4 right angles. So since rectangle is part of the parallelogram family, all of the parallelogram rules apply. Okay? And then the other thing we know specifically about a rectangle is that the diagonals are congruent. Okay. So parallelogram, 4 right angles. Okay. So that means this is a right angle, this is a right angle, this is a right angle, this is a right angle in order to be a rectangle. Then we know that the diagonals are congruent, which means this equals this equals this equals this. So here in my given information, I know that IL is 2x minus 5. I know that FH, which is all of this, equals 10. Okay? So keep in mind that since a rectangle is a parallelogram, it follows the parallelogram rules, which tells us that the diagonals are bisected. So if this is 10, that means this is 5, this is 5, this is 5, and this is 5 too. Right? Which means then that 2x minus 5 equals 5. Add 5 to both sides. 2x equals 10 divided by 2. Oh, it just so happens that it also equals 5. So x equals 5. Next here, ask for LG. Okay, so here's LG. Okay, so part of it, rectangle diagonals are congruent. So since this half was 5, that means LG is 5. Which then, since I want IG in the next problem, which is all of this, okay, if this is 5 and this is 5, 5 plus 5 gives me 10. Okay. Now we're moving on to our trapezoid. Okay. So specifically, these rules are for an isosceles trapezoid. Okay. So for an isosceles trapezoid, what we know is that base angles are congruent. Okay. We know that angles that share a leg are supplementary. And we know that for their diagonals, the diagonals are congruent. Okay. So here, definition of trapezoid is that it has exactly one pair of parallel sides. Okay, the parallel sides are known as our bases. So this would be the base, this would be the base, this would be the leg, this would be the leg. Okay, so bases are the ones that are parallel, the legs are the other ones. Okay, so we know that base angles are congruent, which means then this and this is congruent, which means that angle 3 would also be 77 degrees. Okay. We know that angle 1 then and angle 2 would be congruent. Okay. And how we can find that is that angles that share a leg are supplementary. So here, angle 2 and angle 3 share this leg. So that means angle 2 and angle 3 should add up to 180. We know that angle 3 is 77 degrees. Okay. And then when I subtract that 77, it gives me 103. So angle 2 is 103 degrees. Okay. Base angles are congruent, so that means angle 1 would be 103 degrees as well. Okay. Next one is the same. Okay, so here, this time, these are the two bases. They're the ones that are parallel, so base and base. Okay, that means these are the legs. Base angles are congruent, so that means this and this is congruent, which means angle 3 is 111 degrees as well. Base legs, so here's the base angles are congruent, so angle 1 and angle 2 are congruent. And we know that angles that share a leg are supplementary, so that means angle 1 plus this 111 here should equal 180. Okay. Subtract 111 on both sides. Angle 1 is 69. So this is 69 degrees, which means this is 69. Then moving on here, okay, find the length of the diagonals of the trapezoid. So this is only for isosceles trapezoids, meaning that the legs are congruent, as we see with the marking here. That makes their diagonals congruent. Okay. So here, TV is x plus 1. US is 2x minus 3. Okay. So diagonals are congruent. That means TV equals US, which means x plus 1 equals 2x minus 3. Okay. Then I just need to solve. Move the x's to the same side. So 1 equals x minus 3. Add 3 to both sides. X equals 4. Okay. I actually want to find the length of the diagonal, so I'm going to take this x and plug it back in. So 4 plus 1 is 5. Okay, since they're congruent, this would be 5, 2. But I can check my answer by plugging it. 2 times 4 is 8. 8 minus 3, yep, it's 5. Same thing with the next one here. Okay, again, isosceles trapezoid because these two are congruent. Okay, which makes the diagonals congruent. So TV is x plus 5. US here is 3x plus 3. TV equals US, so x plus 5 equals 3x plus 3. Okay, and then I'm solving for x. So subtract x here, I get 5 equals 2x plus 3. Get rid of the plus 3 by subtracting 3, 2 equals 2x. Get rid of the times 2 by dividing by 2, 1 equals x. However, I want to know the length of the diagonal, so I plug it back in. So x plus 5, so 1 plus 5 is 6. The diagonal should be congruent, so this should be 6, 2. If I can check my answer, 3 times 1 is 3. 3 plus 3, yep, it's 6. Okay. Then here we are on the last page. And so here I want to find the angle measures for the kite. Special thing about kite, the definition, it's a quadrilateral. Okay, so this is not a parallelogram. So it's a quadrilateral with two pairs of congruent adjacent sides. Okay. Opposite sides are not congruent. And what we know about kites is that the diagonals are perpendicular, so similar to a rhombus. Okay. And exactly one pair of opposite angles are congruent as well. Okay. So let's get started. Okay, so here we have our kite. Okay, it's a quadrilateral, so they should total 360. So here, we're going to use this property here. Exactly one pair of opposite angles are congruent. They are the ones where it's different side lengths. Okay, the angle that's formed by the different side lengths, those ones are congruent. So what that means is that this and this is congruent. So if I use x to represent them, so total 100 plus x plus 40 plus x, they should equal 360 degrees. 360 because quadrilateral, 4 sides, 4 minus 2 is 2. 2 times 180 is that 360. Okay? And this, I know that they're congruent because of this. Okay? So x plus x is 2x. 100 plus 40 is 140. Get rid of the plus 140 by subtracting 140. So 2x equals 220. Divide by 2. X equals 110. So that means this is 110 degrees and this is 110 degrees. How do we find the next one? Okay, so here, again, exactly one pair of opposite angles are congruent. The opposite angles that are congruent are the ones where the different side lengths touch. So that would be this one and this one, because this is 2 tick marks, 1 tick mark, 2 tick marks, 1 tick mark, so it's this one. So that means if this is 110, this is 110 as well. Okay. Again, it's a quadrilateral, so it should total to be 360. Which means that 110 plus 60 plus this 110 plus whatever angle G is, we don't know, should total to be 360. Okay. This is 280. Subtract 280. And so x equals 80 degrees. So angle G here is 80 degrees. So next one here, right, I'm going to find this out. Okay. So again, the diagonals are perpendicular. So that means this is 90, this is 90, this is 90, this is 90. So that tells me angle 1 right off the bat is 90 degrees. Then next, I'm going to do angle 4 here. Okay. So note here that this is an isosceles triangle. These two have 2 tick marks. And so across from congruent sides for triangles are congruent angles. So that means this here is 50 degrees. Okay. Then here in this small triangle should total up to 180. So 50 plus the 90 plus whatever angle 4 is should equal 180. 50 plus 90 is 140, okay, which would make angle 4 equal to 40 degrees. Okay. So the measure of angle 4 is 40 degrees. Okay, so that's how you find angle 4 using the idea that this here is a triangle. And so it should add up to 180. Okay. Then we're going to use that exact same concept to find angle 3, right? Because here, angle 3, angle 1, and this 9 degrees here also forms a triangle. And so, angle 3, which we don't know, plus angle 1 we already know is 90 degrees, plus this 9 degrees should total to be 180. 90 plus 9 is 99, so measure of angle 3 plus 99 degrees equals 180. Subtract 99 on both sides, then angle 3 equals 81 degrees. And so measure of angle 3 is 81 degrees. That is from this. Last one is angle 2. Okay, angle 2 is going to be 9 degrees as well. Okay, the reason why is because this ends up being bisected. How we know is from this 90-degree angle. So angle 2 is also 9 degrees. Because here, they're congruent. Okay. Last one here, give coordinates for the missing points of each quadrilateral. Make sure, right, so here I only do an example of a rhombus and a rectangle, right, but you want to make sure that you can do it for all types of quadrilaterals, whether it's a square, a parallelogram, a kite, or a trapezoid. Okay. So here, right, keep in mind that rhombuses, what we know is that the distance or the length of all sides are congruent, right? So 4 sides are congruent. So here, so since this is A comma B, right, this here is A, right, and this height is B. If it is the same, if all 4 sides are congruent, if this, and this are all the same lengths, in order for this to be a rhombus, then that means if this is A for the X, right, because that's at the same left and right, and this is B, that would make this negative B, comma, negative B. Okay. Then here we see that it is on the axis, so that means my Y value is 0. Okay, this is A, this is the halfway mark. Right, so if this is A, that means double that. This would be 2A. Okay, and that's it for my rhombus. Here for my rectangle, right, so we know that this height is A. This length here is B. Oh, sorry, other way. This is, the height is B, the length here is A. So that means for D here, it'd be A comma 0 height. This one here, it's 0 left and right because it's on the axis. And then it is at a height of B. Okay, and that's it. Okay. That's it for today. Have a great rest of the day. Bye, guys.